How does building construction affect structural firefighting? Have you ever thought about how the way a building is constructed can change the way firefighters respond to a fire? Understanding building construction is essential for firefighters. It helps them anticipate how a fire will behave, how stable the structure is, and what hazards may arise. Buildings are generally classified into 5 types. Type I is fire-resistive, using reinforced concrete and protected steel. These materials resist fire longer but can create challenges for access and ventilation. Type II is non-combustible, while Type III is ordinary construction, often featuring a mix of materials. Type IV, known as heavy timber, uses large wooden beams, and Type V, the most common, is wood frame. Type V buildings are more combustible, leading to faster fire spread and quicker structural failure. Modern construction techniques have shifted towards lightweight engineered wood components and synthetic materials. These materials burn faster and lose their structural integrity much sooner than traditional lumber. For instance, lightweight materials can fail within 6 minutes of exposure to fire, while solid lumber might last around 19 minutes. This rapid deterioration accelerates fire growth and reduces the time firefighters have to act. Open floor plans and large void spaces in many modern buildings allow fire and smoke to spread quickly, both horizontally and vertically. This can create unexpected fire travel paths and lead to flashover, where the entire space ignites almost at once. Firefighters need to quickly identify these risks to apply water effectively and prevent rapid fire progression. Structural collapse is another major concern. Lightweight trusses and engineered joists can fail without the usual warning signs like sagging or creaking. This unpredictability increases the danger for firefighters working inside or on roofs. They must anticipate collapse zones and adjust their tactics, often limiting interior operations or opting for defensive strategies. Practically, firefighters must study building construction in their response areas. They should pre-plan 4 known structures and size up buildings upon arrival. Recognizing construction types, reading smoke, and anticipating fire travel and collapse are vital skills. These factors influence decisions about ventilation, water application, search and rescue, and evacuation. In high-risk professions like logging, deep-sea fishing, or storm chasing, understanding the environment is key. Just as loggers must know tree behavior and storm chasers must read atmospheric signs, firefighters must interpret building construction and fire behavior to succeed. The evolving nature of construction techniques requires continuous training and adaptation, similar to other high-risk jobs dealing with natural or engineered hazards. Building construction significantly affects structural firefighting by influencing fire dynamics, structural stability, and tactical options. Modern lightweight materials and open designs have increased fire spread speed and collapse potential. Firefighters must stay aware and adapt their strategies to protect lives and property effectively.